To prove the formula for the perpendicular distance from a point to a straight line, we won't have to do something new. Let's start by sketching, to make the aim more visible. Assume the line ax plus by plus c equals 0 is the line, and it is located here. Then draw a perpendicular, since the line is perpendicular to a point. Label the point as x1, y1. The question now is, how do we calculate the length of the perpendicular line, since it is the distance required? To calculate the distance, let us first calculate the equation of the line. The initial line is ax plus by plus c equals 0, make y the subject of formula, and express it in the form of y equals mx plus c, by dividing through by and collecting like terms, y equals minus a over bx minus c over b. What is needed in this conversion is just the slope. The slope is minus a over b. This implies that the slope of the perpendicular line is b over a. To get the constant part of this equation, we need to substitute the point x1, y1 into the equation, since it is a point on the line, so it must be satisfying the equation. So we substitute it as follows. And we make k the subject of formula. K equals y1 minus b over ax1. The equation of the perpendicular is now a complete one. Y equals b over ax plus y1 minus b over ax1. Now we have the equation of the perpendicular line. What we have to do now is to solve the two known equations simultaneously, to get their point of intersection. After this, we use the distance formula, to get the required distance. Let's write out the two equations. Take the equation of the line as the first equation. ax plus by plus c equals 0 is the first equation, and the second line, y equals b over ax, plus y1 minus b over ax1, as equation 2. Make y the subject of formula in the first, and substitute y in equation 2 for it. So, y equals minus a over bx minus c over b. We can now equate this to equation 2. Minus a over bx minus c over b equals b over ax plus y1 minus b over ax1. By bringing the factors of x to one side of the equation, b over ax, plus a over bx equals b over ax1, minus c over b minus y1. This further simplifies to b over a plus a over bx equals b over ax1, minus c over b minus y1. So finally, x equals b square x1 minus ac minus a by1, over a square plus b square. Now that we have the value of x, we can easily proceed to finding the value of y. We just substitute it for any of the equation above. So, y equals b over a into bracket b over ax1 minus c over b minus y1 over b over a plus a over b, plus y1 minus b over ax1. By simplifying the right-hand side, this gives y equals a square y1, minus bc, minus a bx1 over a square plus b square. Let's bring these expressions together. X equals b square x1, minus ac, minus a by1, over a square plus b square. Also, y equals a square y1, minus bc, minus a bx1, over a square plus b square. This is the point of intersection of the two lines. Our aim is to find the distance between this point and the point x1, y1. So we can proceed from here, by taking the distance between these points, using the distance formula. So, the distance d, between the 2 points is equal to square root of a square y1, minus bc, minus a bx1, over a square plus b square, minus y1 square, plus b square x1, minus ac, minus a by1, over a square plus b square, minus by 1 square. By simplifying this, d equals square root of a square y1, minus bc, minus 𝗍𝗶𝗥1 minus 𝗍 square plus b square y1 over 𝗍 square plus b square plus b square x1 minus AC minus 𝗍𝗶y1 minus 𝗍 square plus b square x1 over 𝗍 square plus b square. By expanding the innermost bracket, some terms cancels out, and the expression reduces to following: d equals square root of bc plus 𝗍𝗶x1 plus b square y1 over 𝗍 square plus b square plus AC plus 𝗍𝗶y1 plus 𝗍 square x1 over 𝗍 square plus b square square. Let's factor out the denominator. D equals 1 over 𝗍 square over b square root bc plus 𝗍𝗶x1 plus b square y1 square plus 𝗍c plus 𝗍𝗶y1 plus 𝗍 square by 1 square. Without going into details, this can further be simplified and factorized to give d equals 1 over 𝗍 square plus b square root 𝗍 square plus b square times 𝗍x1 plus by1 plus c square. Further simplification steps follow, as the expression becomes simpler. So, after the simplification, we see that distance d is equal to the absolute value of 𝗍x1 plus by1 plus c over square root of 𝗍 square plus b square, and this is valid. This is the expected result. Coordinate geometry is interesting in the sense that it allows a lot of methods in solving a particular problem. Actually, there are other methods to get this done, but this video is meant to be all about this specific method. Now let's proceed to the conclusion. The distance between the line 𝗍x plus by plus c equals 0, and the point x1 y1, is given as the absolute value of 𝗍x plus by plus c, over root 𝗍 square, plus b square. Thank you very much for your time.
I'm gonna stand up for what I stand for. Fight till finish and win the war. I'm gonna